Okay, so now it's time for our final pullback theorem. So let's start with a bit of a recap of how to use the previous result we've just got about when we've got the commuting squares into triangles. So here's a nice kind of graphical summary. When I denote a pullback square, the actual object involved in the pullback with this little perpendicular symbol here. So when we have two pullback squares arranged like this, so there's a common arrow opposite the perpendicular square. And when we have a commuting triangle on the end like this, then the previous result implies that we can draw a commuting triangle on the other side of the picture, like so. And also then that this kind of back, the perimeter of this diagram now also forms a pullback. Okay, so then with that in mind, let's go to our theorem. So our theorem is that is there a good place to illustrate it? Yeah. If we have these four pullback squares as shown, where z is equal to m after h, or equivalently z is equal to n after k, then we have that there exists a u and v which make this diagram commute, make all of these squares commute and stuff, and which is such that every square is a pullback. Okay, every possible pullback square you could have in this cube is a pullback. Okay, so how are we going to show it? Well, we start off with this, and what we're looking for really is this kind of motif, so that we can do this kind of trick and make more pullbacks and stuff like that. So we have this, and we know we have a commuting triangle, which is ZMH. Okay, ZMH is here, like this. Oh, the particular claim, by the way, of this theorem, just before I get carried away, is that HUV is a pullback of S and Q. Okay, so HUV is a pullback of S and Q, and we do arrive at that conclusion, I believe. Yeah, HUV is a pullback of S and Q. Yeah, we get there in the end. Anyway, let's get back to actually how to prove this result, because it's this is what we start with, where we know that Z equals NK equals MH. Okay. So firstly, we want to get U up here. We want to get U. So how are we going to get U? Well, we want to apply our previous result to MHZ. So here is MHZ. It's a commuting triangle. And moreover, if you look at the pullbacks around this, you see that we have a pullback here based on H. And we also have this pullback here based on F. So we're going to sort of swing this H stuff down to the bottom. Imagine it sort of pivoting on F. It's just a redrawing of the diagram. And we can draw it like this, basically. And then we see that this is the right kind of motif to apply our previous results. And that's going to imply that there's a U from H to F, which makes this diagram commute, and also is such that the outer perimeter is going to form a pullback. Okay. So now we know that U's there, we can sort of elaborate our diagram now. And we have this extra pullback here drawn with the dotted green line, and we know about U. So the next thing we do is do the same kind of thing, but this time based around the triangle NKZ. Okay, because we have this H, we have this WF X Z pullback going into B, if we leave that at the top, and then we let this TNSF pullback swing down to the bottom, we have this kind of picture here, which again is ideal for applying the previous result. So we can draw in that arrow there. We know that that diagram commutes. And we also know that the outer perimeter of it, as in KXTV, is going to form a pullback. So now our new picture looks like this. We've got this extra pullback here, and we've got V. So what we do now is we consider this part of the cube which I've drawn with these dotted lines. Now we know that this is a pullback, and we know that this is a pullback, so that implies that the sort of outer rectangle which is drawn here is a pullback from our first result. Next thing is we consider this part of the cube, so going from H to G to D, it's sort of the face on the left and the face that's nearest to us as it's drawn. Now we know that this right face here is a pullback. Now the top of this picture here is T after V, but we know that that is Kx we must have Kx is TV because this top part of the square commutes, because we've already showed it's a pullback. And similarly, we must have FQ is MR. FQ is MR because we know that this bottom face of our cube is a pullback. So we can redraw, or we can replace TV with KX and FQ with MR. And then we have just this. And we've just shown that this outer rectangle is a pullback. So we know that H is a pullback of this stuff. So we now know that H is a pullback of this, sort of the outer perimeter of this diagram. And then our first result gives us that since the outer rectangle commutes, this left rectangle must commute as well. So then we have that this square commutes as well, and this completes the picture. We've shown that every possible sort of corner in this cube is a pullback, and we've shown that the bottom, the left, the top, the back, the front and the right faces all commute. So we've done it all. Very interesting how much information gets implied by all that stuff. So McClarty writes, in other words, the pullback square over B pulls back along F to give a pullback square over A if each of the arrows to B has a pullback along F.